All right, here's what we're looking at tomorrow. Not too long of a test, 35 points, 10 questions. No review questions on there. Okay, strictly surface area and volume. All right, no completing the square or anything like that. I didn't do that this time. One big density question at the end, where for the final time, you're going to have to help Big Al out. Oh, I don't know. He could appear in the Regents. That would be unbelievable if he did. Any sort of his Big Al, Alan, Al appeared. And yes, his identity will be revealed tomorrow. We will have a picture of Big Al. He needs a little help with his windmills. You need to find out how much it's going to cost him to build his windmills. You guys will be given a reference sheet. I'll go nuts if anybody gets a volume formula wrong. Right, Jack? Why? They're all on there. Every single volume formula is on there. Anything before I start chiming in with a couple pointers here or there? Anything that you would want to go over here? While it's up there, I didn't finish it. Number 3, the surface area problem. Anybody remember the cone lateral area? Because these aren't on the form. Only volumes are on the formula sheet. Anybody remember the cone lateral area? Pi. Nope. Oh, actually, yeah, it is pi RL. Sorry. I was thinking about cylinder. Pi RL. Yep. And how about the cylinder? That's pi DH. Yep. What if you needed, ready? What if you needed to do surface area of a cone? Just add in what? A circle. What if you need to do the surface area of a cylinder? Add in 2 circles. The only other one I'm going to put up here now that it comes to mind, we did another figure surface area, and that is sphere. Anybody remember surface area of a sphere? 4 pi r squared. That's not on the formula sheet. I purposely waited to this moment to hand back your surface area quizzes. When I do, please take a look at problem number 9. Okay, take a look at problem number 9 and problem number 8. That's what I'm talking about as far as the surface area problems are concerned. Okay. So when I hand these back, take a look at those before we get reviewing, and I'll answer any questions you have from those. Again, so the surface area question I'm talking about for tomorrow is a figure on top of another figure. What do we have to worry about? When you find that, not the volume, we don't have to care about it, but surface area, what do we have to worry about? What is being covered up? Only find the area of all the showing faces. Okay, only find the area of all the faces that are showing tomorrow. And if you take a look at number 8, I may throw something at you where, look, I'm not painting the top or the bottom. I may be painting the top, but not the bottom. You just got to pay attention to that. All right, so for number 8, it was just lateral area you were finding because the top is open, which means there is no top to be painted, and we're not painting the bottom on number 8. So the only thing you needed to paint was the lateral area of that cylinder. Okay? I know it's been a while, but differences, we okay at differences between lateral versus surface area? I know it's big. It's big. It's obviously a big volume test, but there are going to be some surface area problems in there too. Anything there? Okay, hopefully you're ready to go hardcore here with the review. Go to your packet. What page are we on there? 39. Okay, page 39. Let's do this. I got a couple questions. Now, when we do the second one, that's going to be the one you were asking about when we get to it. At the top of page 39, as usual, there's textbook questions to try, followed by the ones that we provided in there with your packet. All right, I'm starting with number one. We're going to do numbers 1, 2, and then one other one, then you're on your own. Sphere's got a volume 288. Find the length of the radius. I need the volume formula for a sphere first. Again, no reason to get this one wrong as far as the volume goes. Okay, let's go. 20, nope. How about 14? Volume formula of a sphere. 4/3 pi r cubed right off the reference sheet. Where's the 288 pi going to go in that formula? 19, where do I put that 288 pi? For V, I'm solving for R. 288 pi equals 4/3 pi r cubed. All right, I'm not going to say anything. Your move to get R by itself. What do you want to do to get R by itself? A lot of different things we could do first. 8, we're up. Great job as usual. How about 3? What do we want to do first to get R by itself? Cancel the pi's. I like it. They're going to divide out eventually, so I'll have 288 equals 4/3 r cubed. Next up, 29. What do you want to do over there, Anthony? Three-fourths. So I end up with r cubed. What do we got there? 288. I don't have 216. And final thing to get R by itself. We've done this a couple times this unit. May have been new to you, but not anymore. 23, what do you want to do to get R by itself? Take the cube root. We all good on the calculator because I can't answer this tomorrow, how to take the cube root. Well, everyone can hit their math button. Leave it at that. All right, everyone can hit their math button and the choice is there. And what is the radius length here? Let's go with 17. Radius length. 6. 6. Just centimeters because we're just finding the length. So centimeters. Units again. Remember units. Half point off for every unit that's not there. You ready over there, stud? Here's your question, I think, right? I give you the volumes, you want the surface areas. Okay. All right, so I know the volumes are 27 to 8. I need help to get to the surface area. That's what I'm looking for. And I have not given you anything to go directly from one to the other. You need to take a little detour. You need to take a little detour. What can you get from the volume ratio, though? Not surface area, but 13. What can I get from the volume ratio? We have a 13? Oh, sorry, Emily. Similarity. What do I have to do to this? Cube root, 27 and 8. Yep, that'll give me the similarity ratio. Nice job. So what is my similarity ratio when you cube both of those? 1, Maddie? 3 to 2. And then now how do I get to my surface area ratio? If I know the similarity is 3 to 2, 22. What do you have for me? What do I do with my similarity? I square it. So my final answer here is going to be the surface area is 9 to 4. Now tomorrow, I may take this a step further. I may say the surface area of a smaller figure is 25. What's the surface area of the bigger one? So you need this 9 to 4 to set it equal to x over 25. Okay, expect that. I'm going to expect that tomorrow. I'll give you, it was on your notes too, so I'm just making this up off the fly. Let's say I give you the surface area of one of them's, I don't know, 25 square centimeters. Surface area of another is 64 square centimeters. The volume of the first one is, I have 512 cubic centimeters. What's the volume of the second one? So expect something like that. Okay, so now you would take the square root of these, cube them, and then set it equal to 512. All right, just as was in your notes that we did on Friday. Any other questions? I got one more, which I believe is the number 4 there with the tank. Richard's fish tank. Fish tank. From a hose. Anybody fill their fish tanks with hoses? It's a pretty big fish tank if you need a hose, right? I think you would just dump water in there. I don't have any fish. I don't know. No animals at the Carlino household. I'm that guy. How long is it going to take to fill it 15 inches? All right, well, this is going to be volume. I agree with the 24 times 16, but I do not agree with the 18. Why not? We're only going to 15. We're not going to the top, so it's got to be 24 times 16 times 15. And I could fill it at a rate of 500 cubic inches per minute. I'm going to let you guys take it. What are you doing tomorrow then? Because I have no idea what to do with that 500. Multiply it, divide it, I don't know. What can I do if I unsure? 500 cubic inches per 1 minute. Set up the conversion. Inches across from inches. And we're on our way. How many minutes is it going to take to the nearest minute? What do we get, Matt? Nearest minute? 12 minutes? It's a long time to fill up that thing. You would think it'd be quicker. The only last thing before I let you go on your own, whether it be in a textbook or with the rest of these problems, is I've given you all the density problems I've given you. You have 2 days worth. The only one I have left is the one on the quiz tomorrow, the one on the test tomorrow. Okay, and you will have to change units sooner or later, whether it be at the beginning or change like grams to kilograms, something like that. Okay, you will have to change sooner or later. So look at those 2 days of density. I think it's like 15 problems we did in class. All right, I don't have any more. I'm sorry. Okay, so you are on your own right now, whether it be the textbook or the rest of the packet. Answers on the following pages. What do you got, stud? Yep. Is it? Did I not change it? No, test is tomorrow. That's it. No, it's tomorrow and that's it. We do Regents work on Wednesday. Okay? 2-day test. No way. I got better things to do here, Mason. All right, guys, go ahead.